Hi, I'm Rob. This video was originally part of a drum building video where I was skimming the inside of a drum. Specifically, I have this 3D shape going through it. That video was extremely long, so I decided to make a standalone video instead. So I'm starting in the middle of a build process. Some of these things might not sound relevant if you don't know what I'm doing. If you really want to know, go ahead and watch video 3 of the SnakeSkin build video, and you can catch up where we are. But really, I'm talking about editing gcode in a spreadsheet. So if that's something you're interested in doing, it doesn't matter what I'm doing. You can edit it yourself this way. So we'll pick up the video in the middle of a process. Now, I've done the same thing as that compound on the inside, too. So let's hide that bit there. So here's the design I'm working for. This will be outside the drum and the inside. You saw that in the intro. I have that concave shape there. This is what I was going for. In theory, I want it thicker on the edges, and a lot of people do a re-ring at the top to get it stronger on the outside edge there. That's important. You want a strong drum, and a little thinner inside. So if I would have gone straight through, it'd be very thick here, over 3/4 of an inch. And that's too much. That would be a very heavy drum. It would deaden the sound. We don't want that. And this is not a perfect to scale. This is to show you what I'm doing here. So you can see that compound, and it gradually curves in and out. Very attractive. It should be strong with the kind of a re-ring there. So that's the concept I'm going for. Now at this point, if you're still listening, there's a good chance you are a geek, either a drum geek or a CNC geek. I am both, and I try to keep my videos simple and not go too many geeks per minute or GPMs. I'm going to skyrocket the GPM meter pretty quick here. I'm going to dig into how I created the G-code for this, how I edit it, and can do this for multiple drums over time. I should say my day job, I work IT, and specifically, my title is application developer. But what I really do is work with databases and have databases talk to each other and move data back and forth. I'm constantly working with data, tweaking data, all sorts of fun stuff. The term that they often use is ETL. That stands for extract, transform, and load. So I pull data out of one place, extract, transform it somehow, and then load it back into another database or a report or a spreadsheet or whatnot. So I do this all the time. To me, it comes kind of natural, but I know to a lot of people this is going to be crazy and kind of complex. But I'll try to make it as simple as I can and not go too high on the GPMs. I don't claim to be an expert in G-code, so somebody might come out there and say, I'm an idiot, and they actually could be right. But I'll show you what I'm doing and how it works for me. All I know is it worked in the end. So what I want to do is create a toolpath for this, and I will steal the bit of code where it does this arch, and where the Y is, I'm going to change the Y's to Z in the G code, and that'll work for what I'm trying to do. Then I'll repeat it and repeat it over and over again as I wrap around that drum. So here's what I'm using for that. I'm only cutting 1/100 of an inch deep, which is irrelevant. I'm going to throw that part away. What I really care about is on the line. Technically, it's an end mill, but it doesn't matter. On the line could be a V-bit or anything. It's going to the center of the bit on there. I'm going to disregard all this other stuff. And I'm going to call it left, calculate. Now I'm going to close and save it. It already exists, so it's going to say, replace it, doesn't really matter. Okay, so let's go back here. Left, that's what we just created. Oops. So in G-code, there's a setup and a header, and I don't care about that part. I'm going to paste this into my own G-code later. So I'm going to delete that. And that line's still part of the header. And so is this line. I don't care if it's G0 or G1, so I'm going to get rid of that part. So in this G-code, I don't care about Y, because actually I'm going to replace all the Y's with Z's, except for that Z, and that one, setting the Z height, I'm taking care of that manually myself too, so get rid of that line. Get rid of this one, because that's before it's raised down. It's the speed. F stands for the speed that we're going to move in G-code. It's implied that Y is 0 here. I like to have my zeros. It's not needed because if it goes from here to here and Y doesn't change, that means it'll stay on 0. But I want that to be there for my code. So I'm going to copy that and paste that. And at the bottom, kind of the same type of stuff. Here's where it's done. It raises the bit up and it's done. I'm going to delete that. So this is what I really care about here. So if I look at this, let's get rid of that so it's not showing the toolpath. So here is X 2.2414 and Y 0. So if you look down here, you can see where I move my cursor around. That tells you where you are on that. So if I go to this point right here, let's show this again. Go to that point right there. That is 2.2429, which is almost that. I can't get it exactly lined up perfectly, but you can tell that's where it is. And Y is 0. And Y is basically 0. As I move along, say if I found this point here, it's point, around 661 and 279. It's around here, the G code. The very end spot will be where X gets to 0 and Y is at approximately, 0.74 or so, 0.73, X, 0, Y, 0.73. So this is how the G code actually works. It's following that line. It's important that you have this set up as a Bezier curve. Maybe we can close that and I'll show you why. If we're going to dig into this, let's dig real deep. Don't save what I did. I'm going to convert that to a Bezier, to a circular preview. And okay. Looks the same to us. But if I create a toolpath from that now, the G code will be very different. Oops. Now I'll save it. Okay, it's much shorter what we were looking at before, the actual lines of G code. The problem, or it's not a bad thing, but for what I'm doing it's a bad thing, but it's actually much easier to work with for the computer, but suddenly we're working with G3, it could be a G2 also, but that means it's an arc. And it tells the start point, it tells the end point of the arc. So it starts at, say, that point. That's the end point. And this talks about how wide of an arc, how long. I don't understand how it all works. I could look it up and kind of explain it. But there's I and J in there, which involve the angle and the depth of the arc. My code, where I'm going to tweak the code, I can't tweak that. So it's important I have the other G code where it's actually every single point. So even though it's less efficient, I want it the other way. So in the end, I took that G code and I pasted it in right here. This is actually a different bit of G code, but it's very similar. Same basic thought though. X starts at 1.5, so it'd be on the right-hand side of 0, and it comes down that way. So X and 0, X and Z as well. I did one other thing already too. I'm getting ahead of myself. I swapped out all the Y's with Z. So here, it goes down on the y-axis, but if you're looking at this from the other perspective, that could be Z going down. That's the shape I want in depth. So I manually changed every Z, every Y to a Z. Same bit of code, just changed those digits. And again, if we looked at it again on here, we start at X 1.5 and Z 0, X 0 and Z 0.6. So we start here where this X is 1.5 and Z is 0. We go down to here where X hits this line at 0 and Z is depth 0.6, 0.7 on that way. So if you believe that's true, which I hope you do, trust me that I did that, it's the same bit of G code, just cleaned up a little bit. This row, I cleaned it up a little bit more, but it's kind of irrelevant, this row. Really, this line is what really matters. I put a whole column for X, a column for 1.5, which is that same 1.5 there. Z is 0, Z 0. So you should be able to follow this down. It looks exactly the same. I took it one step further. Here's what this one does. It starts here, works down to the angle. On our machine, we want to do the same thing. Then on the second pass, we want to go back up and do the exact same thing in the opposite order. So that's all this bit of code does here. Notice it's 0, 6216, 0, 6216, 0.02, 0.5985, 5217, 436, sorry, 4536, all the way down to, when you go back to 0 and 0 again. Exact same thing, just reverse the order. The only thing that changed is the angle as it rotates the drum. So angle here started at A was 0, here it's 0.33. So it's rotated the drum just a little bit, path back up. It'll do the same thing, 0.66. It'll start at the top and work down. Here it starts then the reverse path again. It just does the same thing over and over and over again. So here's the only thing that really matters. This is the same thing condensed into, well, one bit of G-code. And we'd take this whole thing, copy it, and paste it into a text document that's our G-code file. We'd take it to the machine. I'll use the same header and footer as we saw before. That doesn't change. Now where it gets really fun, or funky, is I've got this whole formula working out here to compile this into one row. You notice I've got a left and a right here. This is for the left side of the drum. This is the right side of the drum. The only difference is the X number, whereas this one starts at 1.5 and comes down. On the other side of the drum, we'll start on X minus 1.5 and come down here. So it reverses the arc. This one, the arc goes this way. The other one goes, whoops, this way. Same thing. Only difference is that number gets reversed. Now the crazy part that I love is the whole formula and whatnot. You'll see got value in here. Because this was a text document, a text thing here, it's treating this as all as text, not as a number. That's alphanumeric versus numeric. Computers care about this. We don't care about it as people, but you can't multiply this number times anything because it thinks it's alpha. It's a name. You can't multiply your name times 2. So I have to convert that to a value. And then I rounded it to 4 digits. So here's H11. So that's H11 right there. And I'm taking the value of that and I'm rounding it to 4 spaces. This part right here is what I really like. So that is F3. I got a dollar sign there, which I'll explain that in a second. But here is F3 right here. So if I want my arch to be a little wider, let's take that. Well, notice this number right now. It's 1.5. I want it to be a little wider, so I'm going to hit 1.1. Now it takes it to 1.65 instead of 1.5. Or if I want to be a lot wider, I'll double it. Now it's 3x the width. Or say I want it only half as deep, so we'll go 0.5. So now it's only 0.75 instead of 1.5. So basically I'm playing with, if I want this to be half as wide, basically all I did was compressed it down to that, or I can take it to double the width that way. So now the arch gets much more shallow. Doing that same thing. And I can do that both directions. So if I change, let's take that back to 1 again. Now notice the Z side over here. Well, let's look down here, it's more dramatic. It's 0.6216. I'll double it. So now it's 1.2. Or if I want it to be half as much, I'll go 0.5. Now it's only 0.3. Now the real Excel geeks know what I've done here, but most people don't understand it. It's kind of a weird concept. Normally I can copy a cell. Let's see how G10, just notice that G10 right there. I'm going to copy this down. I'm going to, let's right click, copy, right click, paste. Yes, I want to do that. So here it was G10. Notice how now it's G11. It does that automatically when you copy down in a spreadsheet. Down here, it's G18. Here, it's copying from G123. So it's smart enough to follow that formula you're copying down. The problem is my multiplier stays the same cell always, so I'm anchoring it down. So to not to count up as you copy down, count down as you copy down, I put a dollar sign in front of it. So F2 or $F, $3. It will not change that F3 anywhere. It's still F3. Same thing on the A-axis or the Z-axis. It's F4, which is F4. So that is the whole process of doing that. One more weird thing I have, I'll probably insert a picture of my spinner right now that spins the drum. You'll see that there is a gear down here on the threaded axis, threaded rod, and it's much smaller than the drum. So it takes 3 rotations of that to turn the drum once. So basically 360 degrees with 1 turn of that, but on the drum, that's 1,000 degrees basically. So I'm going to have 1,000 degrees of code going through this. So instead of counting each step up, whatever, I will copy this G code all the way down to where it's 1,000. Getting to, we're a little past it, right around here somewhere. I will copy here up. I'll paste it into a text file, and that will be my G code. In fact, let's see if I have, yeah, here's my blank rotary G code file. So I have this file, this blank spot. So let's say this spot right here, I'm just going to hit copy. And it's not a truthful example, but I'll paste it right here. And I'm ready to go. I would save that and take it out of the machine, and this would work. That's what I'm using a little bit when you see me cutting the drum. One more quick thing I forgot to mention. I've shown how, in the code, how I do the left and the right. I did the same thing for the center. I'm going to pull it up in the spreadsheet here. I've got one called middle here. Same exact thing. Here we're starting at plus 2.54, which would be right there. Come on down. We're at lowest to the lowest spot, which is minus 0.367 right there. The graph I have there is, oops, goes to not quite 4. And we'll take that back up and back over to minus 2.54 on that one. So that's what I'm using for that code. And let's go back to the side here. I tried doing a graph here, which is a cool concept. The problem is it didn't really work that well. When I changed the multiplier here, so let's go to 2 to make it twice as wide. All it did is change the numbers here, not the actual shape of the graph. So it didn't really work how I expected. I wanted that to actually go a wider graph instead of just changing the numbering system on the chart. So it does show the actual shape we're doing, but it didn't work out in the end. So again, exact same thing I did for pasting the G code in. So I have 3 actual tool paths when I do the drum: the left, the center, and the right. They overlap a little bit, so that helps me out too. Okay, that will be the end of this video. If you have any questions, feel free to make a comment, ask questions. I know this is a strange concept. It isn't used very often. I only use it for things like this that are oddball on weird projects. If you are in VCarve Pro, the closest thing to this would actually be the toolpath. You do a molding toolpath. That's kind of a similar thing and equivalent to what I'm doing by hand here. Okay, so ask questions. If you have any questions? If you actually make it to the end of this video, which I think is going to be only a few select people, make a comment, but to show that you actually got to the end, misspell a word in the comment. That way I know you actually truly made it to the end. And we'll see how many people actually make it. I'm betting there's less than 10 people will make it to the end of this video. Thanks for watching, everyone.